Hi, welcome to another set of video notes. Today we're going over 1.7 and it is how to solve absolute value equations and inequalities. So, you've solved equations and inequalities. The new idea is absolute value. I want to kind of review some things about absolute value. Hopefully you remember that we write it with those little brackets and that if you talk about the absolute value of 5, the definition is really how many units or the distance from 0. So if I'm thinking about the number line and I'm thinking what number is 5 units away from 0? Well, 4, 5, let's count. Oh, it's 5. Sure. But if you go to the left or to the smaller 5 units, -1, -2, -3, -4, -5, you get down here to -5, and -5 is also a true solution. So, most times we're going to have two numbers. Keep that idea of 2 stuck in your head. What I'd like to go over with you now are the steps for solving absolute value equations. We'll do equations first, and then we'll come back and change it for inequalities. First step, write 2 equations. Once again, the magic number is 2 today. We're always going to do 2 things. Step 2, solve each equation. Step 3, check each equation. Now normally, checking, although as algebra teachers we love you to do that, it's kind of extra. It just proves you're right. However, with absolute value, you have to check the numbers in the original equation to make sure they work. Okay, let's come on and we'll look at some examples. Our first example, pretty straightforward. Absolute value of 4x plus 12, it equals 28. Remember, 2. That's our big number today. You want to write 2 equations. One is 4x plus 12 equals 28. That's not hard to come up with. I gave it to you. The other one, you just have to remember, take the opposite of 28, which is -28. Okay, so we've done step 1. We wrote our 2 equations. Now we need to solve them. So, what do we do here? I hope you're getting pretty comfortable with this. We're going to subtract 12 from each side. We get 4x equals 16. Divide each side by 4, and you get x equals 4. Excellent. Let's go on to the other one. What would we do first? We subtract 12. This time, you still have 4x, but -28 minus 12 is now -40. We're going to go ahead and divide by 4 to get the x by itself, and we get x equals -10. Okay? Notice the steps we did are the same. Subtract 12 to each side, divide each side by 4. Check it out. Subtract 12 from each side, divide each side by 4. Your steps should be the same each time. What should be different is that number all by itself. Because one time we started out with positive 28, one time negative 28. Now, we've completed step 2. We still need to check them though. Take the number and put it back in the original. If we have the absolute value of 4 times 4 plus 12, does it give us 28? Well, 4 times 4, 16, plus 12. 16 plus 12 is 28. And the absolute value is what you need. Let's try -10. 4 times -10 plus 12, does it equal 28? And sometimes you might see in a math book, they put that question mark above. What is 4 times -10? -40. What's -40 plus 12? Well, I think it's -28. And here's my question. Is the absolute value of -28 28? It is, so this works. Okay? We're going to now look at a little different example. Hopefully looking at this you notice, oh whoa, wait, there's x's on both sides. So, same steps as before, write 2 different equations. Here's one given to you, just write it. Second one, do you remember what we do to get the other number? Right, you take the negative or the opposite of it, okay? We're going to subtract 4x from both sides. You get 10 equals 2x. What do you do to get the x by itself? You got it. Divide by 2, and you get x equals 5. We're going to do the same steps over here. We're going to subtract 4x, and you're left with 10. Negative 6x minus 4x is negative 10x. Now this time it's going to be a little different. Divide by negative 10, and you get x equals negative 1. Now remember, we have to check these. So go back to the original and we say absolute value of 4 times 5 plus 10 equals 6 times 5. Well, 4 times 5 is 20. 20 plus 10 is 30. Is the absolute value of 30 equal to 30? It works. Let's try negative 1. 4 times negative 1 plus 10. Absolute value of that equals 6 times negative 1. 4 times negative 1 is 4 plus 10. Now, what is the absolute value? Or we'll add them together. Sorry. Getting ahead of myself. It's so exciting. Absolute value of 6. Could it equal negative 6? No. So we call this an extraneous solution. Okay, because it's extra, it really won't work. And I'll tell you, most of the time this happens is going to be when you have an x on the other side of the absolute value. It's just kind of your trick. Okay, so we practiced our absolute value equations. Now we need to practice our absolute value inequalities. Now, in your book, there's a key concept that kind of reviews some things. I want to point it out to you because it's pretty important, and I think we will go ahead and try to get it down in your notes right now. So what we're going to do, hopefully this doesn't make you like sick while we're doing this. Let's move the camera back. We're going to get rid of this, and we're going to point out a few things. If you have something like this and have it less than C, you know you got to write 2 of something. This is kind of nice. You just make it less than C, add another less than, and now you've got a negative C. And if you recall, when you go to graph this, we'll just put down some more letters, whatever your solution turns out to be. When you've got it written like this, that it's right in between, you're going to have a graph that looks like this, where it's right in between. Likewise, if you have it less than or equal to, rewrite it, and now rewrite it, but the only difference is or equal to. So how will the graph change? You're right, you've got to close the circles. So we'll just label this, oh, there should be negative D, sorry. We're going to have closed circles and all the space in between. Okay, so if it started out with less than or less than and equal to, not too bad, okay? We need to look at what to do when you get greater than. Well, remember, we're going to write 2, so write the one that you have. And we don't usually see another greater than sign here. So what we're going to do is think opposite. We're going to write less than the negative of C. Okay? If you have greater than or equal to, you rewrite what you've got. And then remember your second one, less than or equal to negative C. When you graph these, this is the kind that should have them shooting out opposite directions. Okay? Whether you have open circles, or in the case of or equal to, closed circles. Okay? So, what I could do is just change this equation because our steps are pretty much the same for inequalities. You are still going to write 2 inequalities, and here we'll just make it right. We're going to jump in to the middle and say, remember to either keep it, how do we want to say that? Keep it with less than, or do 2 opposites, okay? And then you can solve it and then you can check it. Okay, let's try some of these, okay? So we'll come over here. We just have 2 quick examples. So this one is a less than. If you think back, that means we could write x plus 2 is less than 6. Now less than is the easy one. Woohoo, go less. You just write this and you've got your -6, okay? What do we need to do to get x by itself? Get rid of the 2. Okay, so we're going to subtract 2, and we have to do it to every part, but this time we've got 3 parts. How crazy is that? So what is -6 minus 2? It's -8. What is 6 minus 2? It's 4. Okay, now these are going to be open circles. So 1, 2, 3, 4. And we've got 1, 2, 3, 4, 5, 6, 7, 8, -8, open circle. And it's the numbers right in there, because what we're saying is x needs to be less than 4, go this way, and, this is one of those and conjunctions, x has to be greater than -8, okay? You know, you could write this as x plus 2 is less than 6, and x plus 2 is less than, and then is greater than -6. You'll get the same answer, but I don't think the graphing comes as easy. Okay, let's do one last example. Here we are. This is a greater than, and great requires a little more work. We're going to write the first inequality. It's right there. The second one, remember, switch, double switch the symbol, and switch the sign. We're going to add 7 to both sides, and you get 3x is greater than or equal to 12. You need to divide each side by 3, and you get x is greater than or equal to 4. When we come over here, same thing, we're going to add the 7. What you do to one side, you do to the other. You get 3x less than or equal to 2, and we're going to divide by 3. X less than or equal to 2/3. Okay, so let's draw this. We need to put in our 0. Let's come down here to 4. Open or close dot? Closed. And it's greater, so you go to the right. 2/3, good. It's right here between 0 and 1. Close dot, and we're going to the left. Greater than should always shoot out. Less than should always be in between. Okay? We're going to practice this some more, so don't worry yet. We'll do some word problems in class 2, but we just wanted you to see how to start thinking about solving absolute value equations and inequalities. See you in class.